I'm going to rewrite it on the board. Let's do it like this. Anytime you see x squared minus y squared, basically you just do x plus y, x minus y. This is the rule that we're following. That's really just comes from, all of the stuff we're talking about. Now let's go and work a problem. What if you have y squared minus 49 and you're asked, factor this guy? First you might say, there's no way I can factor, but then you realize 49 is a perfect square. So you can rewrite this y squared minus 7 squared, because 7 times 7 is 49. You have a difference of two squares. You can write the answer immediately. Y plus 7, y minus 7. Y plus 7, y minus 7, just like that. And that's the answer. And if you do FOIL here, you will get back exactly what we started with, just like we did in the previous example. All right, now let's say you have 25t squared minus 36u squared. Now this one looks totally different, but again, you obviously are able to factor it, otherwise I wouldn't present it to you. So you start looking and you realize 25 and 36, they both look like perfect squares. That's a big clue. And obviously you have t squared and u squared, so how would I rewrite this? I could easily write this as 5t all squared minus 6u all squared. Because this square, since it applies to everything inside, is going to go to the 5, making 25. It's going to go to the t, making t squared. This one's going to go to the 6, making 36. It's going to go to the u there. So basically, these two things are exactly equivalent to one another. And once you realize that, you have the difference of two things that are squared. So the way you write the final answer is 5t plus 6u multiplied by 5t minus 6u. You literally just say this plus this multiplied by this minus this. And that is the final answer. All right, now what if you have 8x squared minus 32y squared? Again, it doesn't look like I have any kind of perfect squares here, and in fact 8 and 32 are not really perfect squares, so you're kind of stuck. But then, my advice is always just try to do what you can. We know we can pull out an 8 from both of these because 8 times 4 is 32, so let's just do that. Pull out an 8, so what we'll have here is x squared left over, and here, since 8 times 4 is 32, we'll have 4y squared. Now things are starting to look up because I have a square here, and 4 looks like it's a perfect square. So before we get ahead of ourselves, let's write it like this. So we'll open a bracket just to make it clear. We'll have x squared minus 2y squared. Now you can see what I've done here. X squared stays the same, and I change this to 2y all squared because I know when I distribute that exponent in, I'm going to get back with what I started. Basically, I'm just taking the problem, and I've got a hammer in my hand, an algebra hammer, and I'm beating it into the shape that I need it to be in. I need the difference of two squares. I know that 4y squared can be written as 2y all squared. And I want it written that way so that I can easily write the answer. So what I'm going to have is 8, and then here it'll be x plus 2y, x minus 2y. Because it's the difference of two things that are squared. Once you have that written down, once you've got that figured out, then the rest of it is basically just mechanical. What if you have, just to get some more practice, 3r squared minus 12s squared? Doesn't look like I have anything, like a perfect square, but I know I can pull out a 3, so let me see what happens. 3, I'm going to be left with r squared here, minus, over here I'm going to be left with 4s squared, and exactly the same thing pops out. I have a 4 left over, which I know I can use to beat this thing into shape. So what I'm going to have is 3, and then over here r squared minus the 4s squared, I'm going to write it as 2s squared, because I know the exponent will apply to both items. So now I have the difference, which is the subtraction of two things that are squared. And so now it'll just be 3 times r plus 2s, r minus 2s. And that is the final.